Okay, in this series of videos, I want to introduce you to a couple of different types of new means, which you might not have known about before. So, the one I'm sure you're all familiar with is the arithmetic mean. So, let's say we have a list of numbers, um, a let's call it A1, A2, all the way up through AN. Then the arithmetic mean is going to be simply the sum of all those numbers over the number of numbers total. Okay, hopefully nothing groundbreaking yet. Um, but now I want to introduce you all to a new type of mean called the geometric mean. And in contrast, if you have the same list of numbers, that's going to be expressed this way. So instead of adding the terms together, we're going to be actually multiplying them together. So A1 times A2 times A3 all the way up to AN. And now we want to somehow normalize this for the number of terms there are. So instead of dividing by n, in this case, since we're multiplying over and over again, let's take the nth root. Okay. So this is the so-called geometric mean, in contrast with the arithmetic mean, which you all know and love already. Now, let's look at a situation where the geometric mean might show up. Okay. So the question is, say we have a rectangle that is 4 by 9. Okay. So that'll have an area of 36. Now the question is, what will the side length of a square be which has this same area? Okay, so we want to find the side length of a square with area 36. Now, as you might know, the square root of 36 equals 6. So the size of our square is going to be 6 by 6. Okay. Well, if you... Whoops. Sorry, that isn't showing up. Let me draw it further up for you guys. So the size of our square is going to be 6 by 6. Excuse the badly drawn square. Now, you might have noticed already that this is actually equivalent to taking the geometric mean of these two numbers, 4 and 9. Why is that? Well, what are you doing? You're taking the square root of the area. Well, the area is just these two numbers multiplied together. So if we are given the numbers 4 and 9, what the question is asking us to do is multiply them together, so 4 times 9, and then take the square root of them. Well, this is just the definition of the geometric mean for two numbers. Okay. Recall that the geometric mean is just multiplying all the numbers in the sequence together, and then taking the nth root of them, n being the number of terms that you have. So in this case, since we have two numbers, n is 2, and that means we're going to be taking the square root. And that actually is part of the namesake for geometric mean. The whole thing with squares and rectangles is part of the justification for why it's called the geometric mean. Arithmetic mean, I don't know, I guess it's just you do some arithmetic. Okay, so what's another situation where you might come across the geometric mean? Well, say you have stock in some company called, I don't know, the Miss America Talent Show Company. That's Miss America Talent Show, H for show, company. And that stock starts out at some initial value, let's say 100. Starts out at 100. After a year, the stock price goes up by 25%. Okay, so doing pretty good. And after another year, compared to the year one, it has gone up another 80%. Okay, so it looks like math stock is doing pretty well. Now the question is, how could we compare how could we come up with an average percent growth over these 2 years? One way might be to just look at these two numbers, 25% and 80%, and average those two. Then you would get, you would get 52.5%. So you'll be growing 52.5%. So that's one possible answer. But let's see what this would actually be. So if you started with 100, an increase of 25% would mean your stock price is now at 125. And an increase in 80% of 125 would be 125 plus 100, so 225. Now, if you actually plug in an average growth of 52.5% from 100%, that will actually not give you the number 225 after 2 years. So this is actually a situation where we want to use our friend, the geometric mean. Let's see what happens when we use the geometric mean. So we have a growth of 25% and a growth of 80%. Now, since we're talking about ratios here, let's slap a 1 in front of those because we're actually multiplying now by 1.25 and 1.8. And you know what? Let's see what happens when we take the geometric mean of those two numbers. So we'll have 1.25 times 1.8, and we're taking the square root of that because we have two numbers in this case. Well, that's going to be equal to square root of 5 over 4 times 9 over 5. And hey, look, the 5's cancel out, and we get a nice number because I planned it out that way. So we get an average growth, an average quote-unquote growth of 3/2 or 50% increase over the years. Let's see what happens when we crunch these numbers. So remember, with the arithmetic mean, we did not get a nice definition for the average growth. But with the geometric mean, if we start with 100 and we look at what a 50% growth per year gives us, then that'll give us 150 for year 1, and then 150 times 1.5 is 225. So we'll actually end up at the same ending value. So the geometric mean comes up a lot more handy when you're dealing with things like ratios or when you're multiplying things together rather than adding them together.